student, now continue the examples on this sphere. So here is the example. Find the center and radius of this circle, which is intersection of this sphere x square plus y square plus z square minus 2y minus 4z minus 11 equal to 0 by the plane x plus 2y plus 2z equal to 15. That sphere cut by the plane. So note that there will be example on sphere and plane combination. Sphere cut by the plane or touches to the plane. Draw the figure. Figure is not important, but by figure understanding is very clear. So here is the sphere that I will denote by S, and here is the plane U, which is nothing but x plus 2y plus 2z minus 15 equal to 0. And here S is the sphere, means I will denote this as a S. Now this sphere cut by the plane, means the intersection of sphere and plane. So you will get here one circle. So that equation or that center of that circle supposed to be C1, and radius we want to find PC1. So here is the center of sphere. Now consider this type of triangle. So CP is the radius of sphere. So what is given here? Given equation of sphere or given sphere is x square plus y square plus z square minus 2y minus 4z minus 11 equal to 0. Note that whenever the equation of sphere is there, always you find the center and radius of this sphere. So what is the center? C. So coefficient of x, y, z you divide by minus 2. So coefficient of x is absent, so 0. Coefficient of y is minus 2 divided by minus 2, it is 1. And coefficient of z is minus 4 divided by minus 2, so I am getting 2. And radius, it is under root of u square. So you take the square of this. So square of 0 plus square of 1 plus square of 2 minus constant term. So what is the constant term here? Minus 11. So minus of minus 11. So minus constant term. So I am getting radius r equal to under root of 16. So r equal to 4. So radius of this sphere, that is r equal to 4. So CP is 4 now. What about this center? It is a 0, 1, 2. Now our interest is to find C1. So you know what is the equation of line passing through this point and having direction ratios 1, 2 and this 2. Note that this CC1 is a perpendicular to the plane, and therefore the direction ratios normal to this plane. Normal to this plane means perpendicular to this plane are coefficient of x, y, z, means 1, 2, 2. So I am getting here equation of line CC1 passing through the point. Note that when we want to find the equation of line, you always consider the known value of point. So here CC1, which point we know? C we know. So passing through the point C, 0, 1, 2 and having direction ratios 1, 2, 2 is, so what is that equation? X minus 0 by 1 equal to y minus 1 by 2 equal to z minus 2 by 2. So x minus 0, y minus 1, z minus 2 upon 1, 2, 2. And that is supposed to be k. So I can find value of this or point of this C1 in the form of k. So what is this C1? So therefore C1 equal to k plus 0, 2k plus 1 and 2k plus 2. Note that here. This 1 into k, 2 into k, 2 into k. So this 1 into k, 2 into k, 2 into k plus 0, 1, 2. So now we have C1. Note that in geometry, you can find this center and radius by different way. So it depends on your thinking process. So here what I am going to see, I have this C1 point. So definitely this C1 point is on the plane. So it satisfies equation of plane. Since C1 satisfies equation of plane, which plane? X plus 2y plus 2z minus 15 equal to 0. And therefore this x, y, z you substitute here. So I am getting k plus 2. Y means 2k plus 1 plus 2. Z means 2k plus 2 minus 15 equal to 0. Simplified. So I am getting k plus 4k plus 2 plus 4k plus 4 minus 15 equal to 0. So 9k minus 9 equal to 0. This implies that k equal to 9 by 9. It means that 1. So what is value of k, it is a 1. And once we have value of k, I can find this C1, and therefore this point means center of circle, that I am going to denote C1, and that is equal to k is 1. So 1, 3, 4. So we have now this C1, 1, 3, 4. Now our job is to find this PC1. We have this value. By distance formula, we can find this CC1. So definitely by Pythagoras theorem, we can find this C1P. So right there, by distance formula, CC1 equal to under root of. So this is for your reference. So I am getting 1 minus 0, it is 1 square, plus 3 minus 1 means 2 square, plus 4 minus 2 means 2 square. So distance is what? Under root of 9. So that is equal to 3. So we have this distance 3. So in triangle, or you can say in right angle triangle, PC1C, PC whole square equal to PC1 whole square plus CC1 whole square. So put the values. PC we have 4. So it is a 4 square equal to PC1 we want to find, and CC1 it is a 3. So 3 square it is a 9. So what is the PC1 whole square? So I am getting here 4 square minus 3 square. Means it is a 16 minus 9. So I am getting PC1 whole square equal to what we want to find? We want to find center and radius of the circle. So required is what? So therefore center of the circle, that is C1, is 1, 3, 4, and radius is, that is the PC1, is a radius of that circle. So which is your required answer. So here is a new example. Find the equation of sphere which passed through the point 6, 4, 3 and meets the plane x plus 2y minus 2z plus 11 equal to 0 in a circle of radius 4 units with center at 1, minus 1, 5. So note that again here the sphere and one plane. That plane cut to that sphere. So we will get here the circle, and radius and center of that circle is given, and we want to find equation of sphere. It means that center and radius of that sphere. That is our main target. Draw the figure. One sphere cut by the plane. So here is the given sphere which we want to find. Equation of that sphere we want to find, and cut by this plane. So what is that plane? Plane is here. So that is why we will get one circle. Here supposed to be center of this sphere. This C1 is the center of circle. This C1P is the radius of that circle. Now draw the perpendicular and join this CP. So we will get here one triangle, right angle triangle. So what is given here, you put by this figure, it will be more clear. So find the equation of sphere passes through one point. So normally I will consider that point is Q. So 6, 4, 3. This is a point and meets the plane. So this plane is given here. What is that equation? X plus 2y minus 2z plus 11 equal to 0. So definitely this CC1 is perpendicular to that plane. It means that it is a normal to that plane, and definitely the direction ratios of that line or this CC1 are 1, 2, minus 2. Note that before to this video, you must go through the first video of this sphere. So here radius of the circle is given 4. So PC1 is a 4 and center also given. What is it? 1, minus 1, 5. So by this information, we have to find center and radius of the sphere. So solution what is given there. Now what is our main target? That is the CC1. Equation of line CC1. We know the equation of line CC1 passing through known point. Which known point? C1. 1, minus 1, 5 and having direction ratios. Here the coefficient of this plane 1, 2, minus 2 is x minus 1 by 1 equal to y minus of minus 1 means plus 1 by 2 equal to z minus 5 by minus 2, and that is equal to k. So I can find here C means that is the center of this sphere. So C is one point on that line. So that point is k plus 1, 2k minus 1 and minus 2k plus 5. Note that it means that 1 into k plus 1. Similarly y and z. So now we have this C. Now our main target is this triangle. So we have this PC1. We can find the CP. How? Because CP is the radius of the sphere and here CQ also the radius of the sphere. And we know the Q point, we have C in the form of K. So by distance formula CQ we can find. Also we can find CC1 by distance formula. So right there, by distance formula. What is CC1? Equal to under root of. You should know the distance formula. This is for your reference. So I can find here K plus 1 minus 1 means K square plus 2K minus 1 plus 1 means 2K whole square plus minus 2K plus 5 minus 5. Note that I am taking this K plus 1 minus 1, 2K minus 1, minus of minus 1 means plus 1, minus 2K plus 5 minus 5. So here the square. So find this one. So I am getting it is under root of 9K square means it is equal to 3K. So we have now CC1 equal to 3K. Now our next target is CP. So again by distance formula, what is CQ? Note that by distance formula we can find CQ. It is the radius of sphere. It is under root of K plus 1 minus 6, 2K minus 1 minus 4 and minus 2K plus 5 minus 3. That I am taking now. X2 minus X1. So here K plus 1 minus 6. It is a K minus 5 whole square plus 2K minus 1 minus 4. So 2K minus 5 whole square plus minus 2K plus 5 minus 3 means plus 2 whole square. So this is our CQ. Note that here CP equal to CQ and that is nothing but the radius of sphere. Means both are equal. Now our triangle. So in right angle triangle PCC1. PC whole square equal to PC1 whole square plus CC1 whole square. So what is the PC? PC is the radius of the sphere. PC means here CP. PC or CP both same. So that is nothing but CQ. And CQ is here. It is a square of H. So I am getting K minus 5 whole square plus 2K minus 5 whole square plus minus 2K plus 2 whole square. That is equal to PC1. PC1 we have 4. So 4 square and a plus CC1 whole square. So what is CC1? It is a 3K whole square. Simplify it and find the value of K. So I am getting here K square minus 10K plus 25 plus 4K square minus 20K plus 25 plus 4K square minus 8K plus 4 equal to 16 plus 9K square. So 9K square and here 4 plus 4 plus 1. It is 9K square get cancelled. Now K. By using calculator or directly you can find this. Minus 10 minus 20 minus 8. Minus 38K plus 25 plus 25 plus 4 minus 16 or and 25 plus 25 plus 4 54 equal to 16. So I am getting minus 38K equal to 16 minus 54 minus 38 and this implies that K equal to 1. By using this I can find center of this sphere. What is it? It is a C equal to, so K equal to 1. So I will put here, so I am getting here 2, 1, 3. So center is what? 2, 1, 3. And what about the radius? The radius of this sphere, that is equal to, you can consider any value. Either this CQ, which is nothing but radius of this sphere, or by distance formula again you find this one. But better way, it is this one, CQ. Put here K equal to 1. So I am getting it is CP or CQ, that is equal to under root of K is 1. So minus 4 square, it is 16 plus, here K is 1. So 2 minus 5 minus 3 square means 9 plus, here K is 1 minus 2 plus 2 it is 0. So 16 plus 9, it is under root of 25 means CQ equal to 5. Once we have the center and radius of this sphere, we can find equation of this sphere. So what is the equation of this sphere? Or you can say required sphere is x minus 2 whole square plus y minus 1 whole square plus z minus 3 whole square equal to radius square means 5 square. Solve this one. So I am getting it is directly x square plus y square plus z square minus 4x minus 2y minus 6z, and constant term is 4 plus 1 plus 9 minus 25. It is a minus 11 equal to 0, which is a required equation of this sphere. Now the next example, show that the plane 4x minus 3y plus 6z minus 35 equal to 0 is a tangential to the sphere x square plus y square plus z square minus y minus 2z minus 14 equal to 0, and find the point of contact. Here plane is given and also sphere is given. Only we want to show that plane is a tangential plane. So how? Very simple. So draw the figure. By figure it will be more clear. So here center of the sphere, S is given, equation of sphere is given, and equation of plane is 4x minus 3y plus 6z minus 35 equal to 0. Suppose this point is P, which we want to find point of contact. So draw the perpendicular. So this CP is a perpendicular, means from the center of the sphere on the plane. If suppose this distance, CP distance is equal to radius of this sphere, then this plane touches to the sphere. So how many situations are there? Possible situation, one sphere is there, here is a plane, and if we draw the perpendicular, so that distance is greater than radius. Here the radius and its distance is greater than. It means that that plane is away from that sphere. Second is what? One sphere, and here the plane, and if we from the center, if we draw, suppose radius is greater and that distance is less than the radius, then it is supposed to be cut to this sphere, that plane cut to this sphere. And in this case, if radius and that perpendicular distance, radius of the sphere and perpendicular distance both are equal, then it touches or tangential to the plane. In geometry, very important thing is that what actually we want to find, that you should get, and by different way. It is not necessary you should use the same method, but in geometry you can use the different method also. Important part is what we want to find. So our target is what? Radius of the sphere and perpendicular distance from the center to the plane. So sphere, given sphere is, what is that sphere? It is x square plus y square plus z square minus y minus 2z minus 14 equal to 0. Once we get equation of sphere, you always find center and radius of that sphere. So what is the center of sphere? So I am getting coefficient of x, y, z divided by minus 2. It is a 0, 1 by 2 and 1. Coefficient of x is 0 by 2. Coefficient of y is minus 1 by minus 2. It is 1 by 2. And minus 2 by minus 2, it is 1. And what about the radius? It is under root of, take the square of this, addition. So I am getting 0 square plus 1 by 2 square plus 1 square minus constant term. So minus is, constant term is minus 14. So minus of minus 14. So what I am getting? So that is equal to under root of 61 by 4. Or one may consider under root of 61 whole divides 2. It is the radius of this sphere. Now the perpendicular distance. You know the formula of perpendicular distance. In the first video I already given it, the length of the perpendicular. The length of the perpendicular from the point P x1, y1, z1 on the plane ax plus by plus cz plus d equal to 0 is mod of ax1 plus by1 plus cz1 plus d upon under root of a square plus b square plus c square. So now length of the perpendicular from the point, that is the center, 0, half, 1 to the plane, 4x minus 3y plus 6z minus 35 equal to 0. So what is that perpendicular distance? I will denote by P. So it is nothing but mod of 4 into 0 minus 3 into half plus 6 into z means 1 minus 35 upon under root of coefficient of x, y, z square. So it is a 16, 4 square, plus minus 3 square, it is a 9, plus 6 square, it is a 36. So by calculator you simplify it. So what I am getting? P equal to. So simplify this. I am using here calculator. So I am getting minus 3 into 1 by 2 plus 6 minus 35 in numerator. So it is nothing but minus 61 by 2 upon root 61. So that is nothing but root of 61 by 2. So it is the length of the perpendicular. Length always positive. That is why here mod. So length of the perpendicular from the center, and that is equal to the radius of the sphere. So you can consider here supposed to be equation number 1, and here length of the perpendicular, it is equation number 2. So from the equation 1 and 2, it is very clear that the plane is a tangential plane. So from the equation 1 and 2, it is very clear that this plane or given plane is a tangential plane. Now what we want to find? We want to find point of contact, means this point P also. So how? So equation of line CP passing through known point C 0, 1 by 2, 1 and having direction ratios 4, minus 3, 6 is x minus 0 by 4 equal to y minus half by minus 3 equal to z minus 1 by 6, and that is a k. And suppose that point P is in the form of k, 4k plus 0 minus 3k plus half and 6k plus 1. So definitely this point P satisfy equation of plane 4x minus 3y plus 6z minus 35 equal to 0. So put here x, y, z value. So I am getting 4 into 4k minus 3 into y means minus 3k plus 1 by 2 plus 6z means ck plus 1 minus 35 equal to 0. What I am getting? So I am getting here 16k minus minus plus 9k minus 3 by 2 plus 36k plus 6 minus 35 equal to 0. So I am getting 61k minus 61 by 2 equal to 0. This implies that 61k equal to 61 by 2 and therefore k equal to 1 by 2. And once we have a value of k, then point of contact P is nothing but you put the value of k here. So I am getting 4 into 1 by 2, it is a 2, minus 3 into 1 by 2 plus half, it's a minus 1 and 6k plus 1, it is a 4. So this is your point of contact. So both parts over there. So first part is what we want to show, that is the tangential, given plane is the tangential plane. So here is the tangential plane and point of contact, which is your required answer.